The purpose of this video is to describe the manual QA procedure using CubeVue software to measure the quality assurance output of the pedCAT scanner. If you have acquisition software version 6.0 or higher, there is also an automated system that is used immediately following panel calibration. This video focuses just on the manual procedure using CubeVue software. This video was recorded using CubeVue version 2.8.09. Some of the features described in this version of the software are also available in earlier versions of the software as well. In order to perform a complete QA procedure, you will be required to scan both QA phantoms. One phantom is the water phantom, and the other phantom pictured here is what we call the line pair phantom. It has some metal strips running through the middle part of the body of the phantom, and 4 different density materials spaced around the periphery of the phantom. The typical protocol that you would use for a manual QA procedure is to scan the objects at medium field of view 120 kVp. If, however, you are experiencing problems and tech support advises you to scan the other field of view, you would also select the large field of view at 120 kVp. All of your measurements for the manual QA procedure will be performed on the axial view that's in the upper right hand corner. However, it's important to make sure, especially with the line pair phantom, that the line pair strips are visible. So we're going to grab the red line here in the corona view and drag it down till that red line is running through the middle of the metal strips. They are now visible in the axial view. We will then double click the image to bring it full screen. Once we've got the axial image full screen, we're also going to zoom in a bit until all 4 of the different density materials are spread out to the corners. We should always make our measurements on a zoomed in axial view. It makes it easier to use the drawing tools on the image, and it ensures our accuracy. It is also strongly recommended that when you place the line pair phantom in the pedCAT scanning device, that you do so where the metal strips run in a row horizontal to or parallel to the opening of the machine. You do not want them to go at a diagonal or straight up and down. Best results will be maintained when you have the metal strips running in a horizontal line like you see here. We're going to do 3 different measurements on this line pair phantom. First thing we're going to do is to measure the density of these 4 different materials. Then we're going to do an evaluation of the resolution, and that's based on the metal strips and the space in between them. Then we're going to do a distance measurement from one edge of the metal strips to the other. Starting off with the density measurements, we're going to look for the HU tools. They are found at the top toolbar just to the right of center. Clicking on HU, we see QA set small, which is for the smaller phantom, that is the line pair phantom, and we also see QA set large, which is used for the larger phantom, which is the water phantom. So we now click on the QA set small, and we see 4 different colored fields of view will appear automatically drawn onto the object that we're measuring. So the first thing that I need to do is to make sure that all of our 4 different color circles, that the fields of view, are properly centered within each of the different density materials. As I place my mouse on the edge of the circle, notice how it changes shape. When I get the single extended finger, I can left click, hold the mouse button down, and move the circle. I can also do this with each of the remaining circles as well. The one in the low right corner is a little tough to see sometimes, so if you pull it off to the side, you can probably see it better before you bring it back to recenter it. Of special importance to note, there are 2 things that you do not want to do. The first thing that you do not want to do is you do not want to place that circle where it includes some of the material of the different density object and some of the material of the object that the line pair phantom is made of. You want to only be measuring the different density material. So make sure you grab it and center it completely. Make sure it is not sticking over the edge of the circle. Now if you'll notice, when I place my mouse on the edge of the circle, there's a small red dot that appears on the right hand edge. If I put my mouse over that red dot, notice how the mouse changes shape. If I were to grab that red dot, I would not be moving the circle. I would be changing the circle into an elliptical shape like you see here. This is something that we do not want to do. We want to keep it in its circle shape, so make sure you do not grab that red circle and inadvertently change the shape of the measuring tool. If by chance you can't get that circle back to the proper shape, notice that it sometimes gets larger and smaller, and it includes material that's not necessarily part of the density range that we're measuring. What you can do is go to the upper right hand corner where the measurements are, right click, select remove all measurements, then we go back to HU, QA set small, and we'll reposition the circles again. Again, taking care that we are centered as best possible within the different density materials. Now what we are measuring is 4 different density materials. The black circle is actually air. There's a hole through the line pair phantom. We're going to be measuring the density of air. The white chamber that you see up here, that's Teflon, and the reading that we get should fall within a certain range as well. The darker of the 2 circles to the right, the dark gray circle as it's called, is LDPE, or low density polyurethane. And the circle that is the hardest to see, the one in the lower right hand corner here, that is the acrylic material. It is very close in density to the material that the line pair phantom is made of. So what we're going to do is we're going to look for each of the 4 different colors. We have orange, we have pink, we have green, and we have blue. And these will give us corresponding measurements in the upper right hand corner. The measurement that we are specifically looking for is the M value, M1, M2, M3, and M4. The values and the ranges that we are looking for can be found in the pedCAT manual. If you need another copy of the manual, please be sure to contact CurveBeam technical support. The Teflon that we're looking for here, the measurement from the orange circle, should be between 700 and 1200 HU, or density values. So looking at the orange value, we see that it does in fact fall between 700 and 1200. So this value is good. Looking at the LDPE, or low density polyurethane, this value should be between minus 250 and minus 50. So looking again at the blue value, this is also in fact between minus 250 and minus 50. The value of air, in this case it's a pink circle, we are looking for the value of minus 1100 to minus 900. So looking at the pink values, we are in fact within the range of minus 900 to minus 1100. And finally the green circle, which is acrylic in this case, we are looking for a value between minus 50 and plus 200. It could go either way, a little on the minus side or on the plus side. So acrylic again is between minus 50 and plus 200. Looking at the green circle, we see that the value of 129 does in fact fall within that range. At this point we would then record the 4 different values. If by chance any one of these 4 values falls outside the range, you should contact CurveBeam technical support. But before you do that, you should check and make sure that the lines are visible from the line pair portion of the phantom. If by chance you are above or below the line pair level, this will affect the density readings. So it is important, again, that you are centered where the line pairs are visible when you are evaluating the density of the material. Once we have finished recording the different density values, we are then going to evaluate the resolution of the system based on the line pair portion of the phantom. So the first thing we're going to do is zoom in even more so that the different lines are readily visible. What we'll do next is we'll adjust the window leveling so we can get a better view of the different metal strips. Notice how they appear to be almost glowing or saturated. We want to reduce the contrast, so I'm going to go up to window level, select that, left click and drag to the left, and then up or down to make them lighter or darker. What I'm looking for is I want to be able to see as many of these strips as possible, and also space between each strip and the strip next to it. The unit of measure that we're going to be using here is line pairs per centimeter. Where the lines are the thickest and furthest apart is 8 line pairs per centimeter, 9 line pairs, 10, 11, 12, 13, 14, 15, and finally 16 line pairs per centimeter. In this case, we can clearly see at the 8 line pair per centimeter value the metal strip and the space between it and the strip next to it. And we can also see that for 9 line pairs per centimeter, 10, 11, 12, even up to 13. 14 is somewhat questionable, and I would say 15 and 16, you cannot clearly see space between the lines or the metal strips and the space in between them. So at this point, I would record 8, 9, 10, 11, 12, 13 line pairs per centimeter. At this point, we're going to make a distance measurement. Clicking on the distance measurement on the top, notice now that my mouse changes to a crosshair shape. I'm going to bring my mouse down to the very edge of the metal strip. If I am too close to the blue cursor line, I'm going to just grab it and move it out of the way. Now I'm going to left click once and let go, and then drag the mouse across, then left click a second time right on the edge and let go again. If by chance you have drawn too far or not far enough, notice when you put your mouse on the line, there's a red dot that appears at the end. You can grab that red dot and change its position until you're measuring exactly from the outer edge to the outer edge. Note you don't want to be going up at an angle either. That will give you a longer measurement than you're actually supposed to be taking. So you want to go straight across. Notice in the upper right hand corner, in addition to the M values as well as the SD, which stands for standard deviation, and the area again for the HU measurements, we now have a measurement that says D1. That is the distance measurement. Again, all measurements that start with a D are distance measurements. The range that we're looking for that distance measurement from the outer edge to the outer edge is between 41.0 and 42.5 millimeters. So looking here, we see 41.7. That again does fall within the range between 41.0 and 42.5. So at this point, we have completed all three tests that we're going to do for the line pair phantom. Again, the first one was measuring the density of the 4 different materials. That's your M values in the upper right hand corner. Then we had the line pair or line strip evaluation, looking not only for the metal strips but also clearly defined space between each strip and the one next to it. We want to see at least 50% of that space between each strip and the one next to it. And finally, from the outer edge of that outermost metal strip to the outer edge of the other outermost metal strip, that measurement should be between 41 and 42.5. Moving on to the water phantom, again we're going to be doing our measurements on the enlarged axial view, so we're going to double click to bring it full screen. And again, going up to HU, we're going to this time select QA set large. We would like to make sure that the blue circle is in the center of the field of view, and we'd also like to make sure that each of the remaining 4 different colored circles are the same distance from the edge. So just as I did with the density circles in the line pair phantom, I am going to move these in slightly away from the edge so they are all more or less uniform with respect to each other and a uniform distance from the edge of the phantom. What we are now going to do is look at the 5 different M values. We have 5 different colored circles this time. We want each of those M values, M1, 2, 3, 4, and 5, to fall between plus 150 and minus 150. The closer to 0, the better. Again, we're looking for each M value to be between plus 150 and minus 150. Once we have verified that each individual region of interest falls within the desired range, we also need to find the highest mean value, which in this case is 8, and the lowest mean value, which in this case is minus 5, subtract the 2 and see what the difference is. In this case, it's 13. We need to make sure the difference between the highest value and the lowest value is no greater than 250 HU. Once we have accomplished this, we would then add up all 5 M values, divide by 5, and record the average value for all of the M's, the average of all 5 M's, in our logbook. In closing, if by chance any of your measurements have fallen outside the expected range, the first thing you should do is to make sure that your measurements have been properly drawn, you've made all the proper window and leveling adjustments, and your measurements have been properly placed on the image of the phantom. This video was recorded on CubeVue version 2809. If you would like to upgrade to CubeVue version 2809, be sure to contact CurveBeam Technical Support for any assistance.